parallel or just series, just to refresh your memory from yesterday. These are all combination circuits on the first few pages, and we'll come back to these and do them. But let's do some that are just parallel or just series. These are multi-loop circuits. We'll try to do some of those today as well. Okay, so let's look at number 97. 97, what is the total current for this circuit? Here you have two resistors in parallel, and I want to know the total current. A couple different ways you could do this. Probably the easiest way is to find the equivalent resistance. When they're in parallel, you say 1 over 3 plus 1 over 6, and that's equal to 2 ohms. Then this is equivalent to a circuit that looks like this. 18 volts and 2 ohms, and I want to know what is the current going through this circuit, and that current will be the answer. So I have I is equal to V over R, 18 over 2, so that's 9 amps. But look, there are some other ways that you could approach this problem. For example, you could say, well, I know that the voltage here is 18 volts and 18 volts. And then you can figure out the current in each resistor. And that could be a question that I would ask too. And so that means that I would have a current of 18 divided by 3, that's 6 amps. 18 divided by 6, that's 3 amps. And then notice that these two currents, 6 and 3, add up to equal to the 9 that I found here. That goes back to our junction rule, that if I have 9 amps coming through this circuit right here, then I have to have a sum that's equal to 9 here as well. Remember, that's called the junction rule, that resistors in series, the current going in is equal to the current going out. Okay? Let's try another one. We're going to go kind of fast, and if you have questions, then by all means, but stop me and we'll address it. But I find that with these, that the more you see it, that at first it seems kind of foreign, but the more that you see it and the more that you do it, the easier it gets for you. So it might still seem a little strange to you right now. Let's try this potential across the 4 ohm resistor. In fact, I think we did this one in class, but let's do it anyway. In this one, I want to know the potential across the 4 ohm resistor. The first step is to figure out what is the current, or really, the first step is to figure out the equivalent resistance. And the equivalent resistance on this one, REQ, is equal to 4 plus 8 plus 12. That's equal to 24 ohms. That means that I can replace all 3 of those resistors with a single 24 ohm resistor. And then that tells me that my current, I, is equal to V over R, 12 over 24, 12 volts over 24 ohms. That's equal to 0.5 amps. So that means that I have 0.5 amps here, 0.5 amps here, and 0.5 amps here. That whatever my current is, it's the same in all of the resistors. Resistors in series have the same current. And so if I have 0.5 amps here, that means that my voltage is 0.5 times 8, or 4 volts. By the way, I could figure out my other voltages. I could say 0.5 times 4 is 2 volts, and 0.5 times 12 is 6 volts. And notice that 6 plus 4 plus 2 is equal to 12. That's got to be true. Oh, okay, yeah. So it's not going to be 4 volts. It's going to be 2 volts. Okie dokie? Yeah? Let's see. Some of these are similar. Ooh, number 102. Y'all have one like this on the OpenStax that's due next week. It says 2 resistors are connected in series with an 18-volt battery. Oh no, this one isn't. It's somewhat similar to it. 2 resistors in series with an 18-volt battery. If this is 6 volts and this is 18 volts, what must the other one be? it has to be 12 volts. Because I know that they have to add up to equal to 18. Let me find one that's like that one you have. No, let's do this one. I'm going to make up one for you that's similar to one that you have. I don't see one right off. Let's say that I have 3 resistors. I know that this, I don't know what this voltage is. So the question is going to be, what's the voltage on the battery? Let's say that I have a resistance of 2 ohms, 2 ohms, and 1 ohm. And let's say that I have 1 volt right there. I have 1 volt right there. Now tell me, what is the voltage across the battery? This is a lot like the problem that we did before, except you're filling in different pieces of the problem. And so here, what we want to do first is figure out what is this current. And then when we figure out that current, that's going to be the current in all the other resistors. And once we know the current in all the other resistors, we can figure out this voltage and this voltage, and then figure out what is our overall voltage of the battery. So my current here for this resistor is V over R. It's equal to 1/2 of an amp. That means I have 1 volt here and 0.5 volts here. I said 1/2 amp times 2. Goodness, bless you. I times R, and then 1/2 amp times 1 to get the point. Sorry, this should be not amps, but what? Volts. So what's the answer? The voltage of the battery? 2.5. You have a similar problem to that on the OpenStacks, and I have some somewhere in old tests, but I don't see them right off. But you should be able to, given a certain piece of the problem, be able to answer, other pieces. Yeah.
Could you do that because there's two ohms?
You could, yeah. You could say, since this one is 1 volt, this one has to be 1 volt as well. And since this one is half the resistance, this one has to be half the voltage. Yeah, you could absolutely do that. All right. Let's do some combination circuits, because what you need to know with series and parallel comes into play for combination circuits too. And they're harder. I think combination circuits are harder. And then we'll come back to maybe do some of these multi-loop circuits, which we haven't done in class yet. All right. Let's do 46 and 7. Consider the circuit. I want to know what is the equivalent resistance. You might be able to look at it and not even write down anything and figure it out. First, I want to figure out what part do I start with initially. Which resistors do I start with? What now? You're right. The 1 and 2 right here. The 1 ohm and the 2 ohm resistor, R3 and R4. But I start with these two because they're only in series. And then 1 plus 2 is equal to 3. And so I have a 3, a 3, and a 3 in parallel. What's the equivalent resistance of a 3, 3, 3 in parallel? It's what? It's 1. 1 over a third plus a third plus a third. And then I have then a 1 and a 3 in series. So what's the answer, y'all? It's 4. The answer is 4. Let me write that down. So first I find these. That's equal to 3 ohms. And then I find the equivalent of this, which is going to be 1 over a third plus a third plus a third. That's equal to 1. And then I have these, which is a 3 and a 1, a 3 ohm and a 1 ohm. The 1 ohm is the equivalent of that big blob on the right. And I add those up and it's equal to 4 ohms. Now, I want to know what is the voltage across R5. R5 is this resistor. Just think about it for a minute, because I think that you can think about how the voltages are distributed. Seeing what I have drawn here, the 3 ohm and the 1 ohm in series, and figure out what is the voltage across that R5 resistor. What's my voltage here? What's my current through the 3 ohm resistor? Let me draw out this circuit. It's 3, right? Because I have a 12 volt battery across a 3 ohm and 1 ohm resistor, and so I have a current of 3 amps. 4 ohms is my equivalent, so my current is equal to V over R. That's equal to 12 divided by 4 ohms, so I have 3 amps. I got 3 amps going through here. 3 amps across 3 ohms. What voltage is that? 9 volts. And then I left across the 1 ohm resistor, I have what? 3 volts. What's my answer for number 47? 3. Right. Because my resistors over here, resistors in parallel, have the same voltage. They have the same voltage as their equivalent resistance. So since my equivalent has 3, I have 3 volts here, 3 volts across this whole thing. But think about what are the voltages. I'll come back to that. And I have 3 volts across this. 3 volts across this resistor, both of these resistors, and this resistor. So the answer to 47 is 3. But what is the voltage across this resistor? It's 1, right? Because, well, you think about it a couple different ways. I know I have 3 volts split up between this 1 and 2 ohm resistor, and one's twice the other, and they have to add up equal to 3. So 1 plus 2 is equal to 3. Or you can think about it, the equivalent of this is 3 ohms. 3 volts across 3 ohms is 1 amp. 1 amp through a 1 ohm resistor is 1 volt. 1 amp through a 2 ohm resistor is 2 volts. That's a good question, and you'll certainly have a question like that on the test, several questions. It'll be like a series of questions like this. Let's do another one. Let's do one that looks a little bit different. Because sometimes they look different, but they really are a lot the same. Ooh, let's do 39. This one looks funky, but it's really not. It's really a lot the same as what we've been doing. So like with the capacitors, what you want to do is start at the big side of your battery, come along, and look for the first junction. And then I like to redraw it. Even today, I like to redraw it. It just makes more sense to me as I redraw them. There's my battery. I have a resistor right there, but no junction yet. But then I hit a junction, and in that junction, I have 2 branches. There's my junction beginning, ending. I have 2 branches in that junction, and no more. In the top branch, I have 2 resistors. In the bottom branch, I just have 1 resistor. And then they come back together again. So that's my circuit. It's 2 ohms, 1, 2 ohms, and 6 ohms. So I want to know the current through the 1 ohm resistor. But first I need to find the equivalent. What's the equivalent of this? Well, the 1 and 2 together make 3. The 3 and the 6 in parallel makes 2. And then the 2 and the 2 make 4. I'm going to write this down, but let me step you through it in words first. I have a 2 ohm and a 2 ohm. This whole thing is 2 ohms. What's the voltage across this resistor? I have a 2 and a 2. This whole thing is 2. They're going to split up that voltage, and since the resistors are identical, they're going to split up the voltage identically. They have the same voltage. And so I'm going to have 6 volts here, and then 6 volts across this whole thing. That means I'm going to have 6 volts across both of these. Let me start writing some of this down. So, just sort of recap what I just said. I have a 2 and a 2. ohm. This is 12 volts. That means I'm going to have 6 volts here and 6 volts here. That means that I have 6 volts across those two resistors. Those resistors together are 3 ohms. And so the current through them is V over R. That's 6 volts over 3 ohms is 2 amps. So that would be the answer to that question, is 2 amps. Oh, this is giving me a headache. Is it? It's giving you a headache? Yeah, it gets easier, but you need lots of practice. And yeah, no pressure or anything, but the test is in like 5 or 6 days. And you really need to be practicing every day between now and then. Every single day. Do not put it off till Tuesday night, because you will not get it on Tuesday night. Okay? It takes time to really begin to see these things. Okay, so that's my answer there. What was the next one? Oh. Okay. How are we feeling about this question? Rachel, you look like you're about to ask.
I'm kind of processing.
I know, it's so fast, and the little details are not difficult. It's really just on the off, and then a few little rules. But fitting them all together is darn hard. But I've seen many, many students do it, so I really don't think it's true. Let's look at the next one, okay? Oh, let's look at this one. Which of these has the smallest current? Which has the smallest current? First of all, can you tell me which one has the biggest current? Of these 4 or 5 resistors, which one has the biggest current? Think junction rule. R1 has the biggest current, right? Because the current coming through here, it splits up in 3 different ways. So I know the current here, here, and here, they have to be smaller than the current through R1. But which of these then, in this branches, will have the smallest current? Is it going to be, we know it's not R1, is it R2, 3, or 5? R2, 3, or 5? The one with the smallest current will have the biggest resistance. The branch with the smallest current will have the biggest resistance. Which one has the biggest resistance? Nope, not 2. R2 is the biggest resistance, but it's not the branch with the biggest resistance. This branch has the biggest resistance because it has 6 ohms. The R3 and the R4 together make up 6 ohms, and so they're going to have the smallest current. If you think of resistors as pipes, it's like the skinniest pipe, and so it gets the least water that flows through it. So this is a very similar question. I'm 40. Which one gets the smallest current? The 40? Or the R2 branch. R2 in this case, because there's no other resistor there. R2 gets the smallest current because, well, one, I know that R1 has the biggest current because it gets all the current. It splits up into 3 ways, and the smallest amount goes through the biggest resistor. Well, let's look at the next question because that's the one I like. If R1 has a voltage of 8 volts, what is the voltage of the battery? This has 8 volts. What is the voltage of the battery? First of all, I can get rid of one of these. Which one can I get rid of? I can get rid of A. Because I know if I have 8 volts across R1, my voltage across the battery has to be more than, wait a minute. It says 10 right there. Let's imagine that we don't, I don't even know if that 10 is right. So let's just imagine that we, all right. So let's say that R1, I don't even know if this goes with the previous question, but it's a good question regardless. What is the voltage of the battery? So we're going to need to find the equivalent resistance. Let me sort of talk you through what we need to do here. I know what the current here is. My current here is 2 amps. 8 over 4 is 2 amps. And so I know that that 2 amps is going to go into this equivalent resistance. And so if I find this equivalent resistance and put 2 amps to it, that will tell me what the remaining voltage is. So that's really all I got to do, is find this equivalent resistance, say then what is the voltage when I have 2 amps, and then add up those 2 voltages. So let's do that. Here I have a 6, 3, and a 2 in parallel. 1 over 6 plus 1 over 3 plus 1 over 2. That's equal to 1 over 2 plus 4 plus 6 divided by 12. I found a common denominator of 12, and so that's equal to 1 ohm. So I have a 4 ohm and a 1 ohm in series. This is 10 volts. Oh, no, I don't know what it is. We don't know that it's 10 volts. All right, this is 4 ohms. This is 1 ohm. I know that this is 8 volts. And because it's 8 volts, I know that it has to be 2 amps because I is equal to V over R. And so since I have 2 amps, I also have 2 amps here because resistors in series have the same current. And if I have 2 amps, that means I have 2 volts because V is equal to IR. And I add up these 2 values to figure out the voltage of the battery, which is 10 volts. I like those questions. I like where I just give you one little piece of information and you have to fill in the rest of the information. Those are sort of the more challenging questions that you'll see on the test. You'll have some easier ones too, thankfully, right? But you'll have some like that are a little more challenging. Ooh, let's look at 43. I like 43 just because it looks different. It makes you take that circuit and flip it around in your mind and figure out exactly what's going on. So the way we'll draw this, just like we've been doing, start at the battery, go through, look for the first junction. It's right there. That's the opening junction. Look for the closing junction. It's right there. That tells me that I have 2 branches in this that look like that, and then I come back to the battery. So if I redraw this, there's my 10 ohm, and then I have a 2 ohm, and a 2 ohm, and a 4 ohm, 2, oh no, that's 10, excuse me. Two ohm, 2 ohm, 4 ohm. And this is 12 volts. 2 and 2 in series. 2 and 2 in series. 4. 2 plus 2 is 4. 4 and 4 in parallel. Not 1, it's 1 over a quarter plus a quarter is 1 over a half is 2. All right, so these all have an equivalent of 2. With a 10 ohm resistor, the total equivalent is 12 ohms. So what's the current in this circuit? 12 volts with 12 ohms. It's 1 amp. Right, so I have, you write that in here. This is 4 ohms. 2 and 2 make 4. This is 1 over a quarter plus a quarter. That's 2 ohms. And then so my final equivalent resistance is 12 ohms, 10 plus 2. And then 12 ohms with 12 volts is 1 amp. No, but that's not what I'm asking for. I'm asking for what is the current through the 4 ohm resistor. What is my voltage across the 10 ohm resistor? 10 volts. Because it's 1 amp, I have 10 volts of potential, or voltage is 10 volts. That means that across the 4 ohm resistor, what is the voltage? Two is right. I have 2 volts here. Let me redraw this circuit a little bit. There's my 10 ohm. This we said was 2 ohms. That's the equivalent of that. If I have 10 volts here, I have to have 2 volts here. And if that 2 ohm resistor, oh, this is all a jumble. If this 2 ohm resistor has 2 volts, this equivalent is the same as this whole big thing up here. And so this side has 2 volts, and these 2 resistors have 2 volts that they share. So I have 2 volts here, 4 ohms. What's the answer? 0.5. 2 divided by 4. V divided by R is I. What's the voltage here across the 2 ohm resistor? 1 volt. And this also has 1 volt, because I know that together they have to make up 2 volts. Okay? Y'all look excited about this. Circuits are kind of fun. Like when you get into them, when you practice them, and you get good at it. It's kind of like the piano, right? I've been learning the piano. If you don't know how to play the piano, it's kind of frustrating, because you just got to go really slow and just focus on every individual key. But once you get good, you can play songs, and that's fun. And so doing a circuit is kind of like playing a song, that you learn how all the little pieces fit together. And then people like to listen to you when you work through circuits, or watch you, or whatever. Or buying it. Okay, let's do this one, number 33. And then there are several follow-up questions. First thing you want to do is find the equivalent resistance. Number 33. Give me just a second. I'm going to step us through, though. 2 and 2 in parallel. 1 over a half plus a half. That's equal to 1. Then a 1 and 1 in series. That's 2. Another 1 and 1 in series up here. That's 2. So I'm left with a 2 and 2. This whole thing is 2 in parallel. And so the equivalent resistance is going to be 1 ohm. 1 ohm. I'll write that down. Let me go and write that down now. So 12 I'm going to have 2 ohms. That's the 1 plus 1, and then 2 ohms there, because R3 and R4 together make 1 ohm. 1 plus 1 is equal to 2. And then so the total equivalent is going to be 1 ohm and 12 volts. So the answer here is A. But what is the potential across R3? Well, I know I have 1 parallel branch here and 1 parallel branch here. The battery is 12 volts. So I got 12 volts up here and 12 volts down here. I have 12 volts across these 2 resistors. This one together is 1 ohm, and this one is also 1 ohm. What's the voltage across this resistor? 6 volts. Because they're identical, they have the same voltage. If I have 6 volts here, what is the total voltage across these 2? 6. That's the tricky part. What is the voltage across this one? Don't say 3. 6. Resistors in parallel don't share voltage. They have the same voltage. I know what you're thinking. You're thinking, I sort of misled you with my language. They don't split up the 6 volts. They each get the 6 volts. We saw that with capacitors too. It's exactly the same with capacitors. Okay, so the voltage across R3 is going to be 6 volts. In fact, you know what? I bet y'all could step through right now and tell me the voltage across every resistor. What is the voltage across R4? 6 volts. It has to be the same as R3. What is the voltage across R5? 6 volts as well. Because it's the same, 1 ohm is the same as the equivalent of R3 and R4. And so they split up the 12 volts into 6 and 6. R1, 6 volts. R2, 6 volts. They all have 6 volts of potential. If I remove R3, what happens to the current through R1? We're going to see this question next week, but y'all think about tomorrow. If I got rid of R3, how is that going to affect R1? Will the current increase, decrease, or stay the same? What do we know about parallel branches in a circuit? How do they respond to one another? Parallel branches. How are they dependent upon one another? Oh, you're right. They do have the same voltage. Parallel branches, sort of misleading you. Parallel branches in a circuit are completely independent. That if you do something in one parallel branch, it doesn't affect the others. Right? We talked about the household. That's why our household circuits are laid out in parallel. So if I were to change, which one am I at? Yeah, if I take out R3 right here, it's actually going to cause the resistance of this thing to increase. So it'll affect the current in this part, but it's not going to affect the current in this part at all. What happens if I take the R3 out? What happens to the current here? Well, it will be affected. Is it going to increase or decrease? If I remove R3, take it out of the circuit, what happens to the current through R5? What happens to the current through this resistor? Does it go up, down, or does it stay the same? I'm taking out R3. So what happens to my equivalent resistance of that branch? What was it before? Well, before it was 2 ohms. But when I take out that resistor, what's the equivalent? It's 3 ohms. That doesn't make sense, right? I get more resistance by taking out a resistor. But the important part is that I'm taking out another path for electricity to flow. And that actually will increase my resistance. If I take out R3, that increases my resistance. And so the current through R5 is going to do what? Decrease. So it will decrease because the resistance increases. If R goes up, I goes down. Ooh, let's try 37. This is like one that we did before. 3, 6, and 2 in parallel. What did we say that was? That was 1, wasn't it? 4 plus 2, 6. Yes. So these 3 in parallel are equivalent to 1 ohm. That's 1 over a third plus a 6 plus a half. So I want to know the voltage across the battery. How am I going to find that? Just like we did before, what's the current in the 3 ohm resistor? Well, I is V divided by R. That's 2 amps. If I have 2 amps there, that means I have 2 amps across the 1 ohm resistor. And so V is equal to I times R. That's 2 times 1, or 2 volts. So what's the voltage of my battery? Oh, actually, I'm looking for the voltage across the 6 ohm resistor. And what is that? 2 volts. The voltage of my battery is what? It's not up there, but what is it? It's 8 volts. Okay? Do you want to do some multi-loop circuits? We have about 15 more minutes. I could show you some multi-loop circuits. I know that you haven't mastered combination circuits, and that's okay. We're going to do them in class more tomorrow, and probably on Monday too. But I can go ahead and introduce to you multi-loop circuits. It's not terribly different from what we've been doing, but there are some new things I'll introduce. Is that okay? That way when you see that in class tomorrow, it'll be a little bit familiar to you. You can process it a little faster. Multi-loop circuits look like this. And in a multi-loop circuit, we have two rules at play. We have the loop rule and the junction rule. The loop rule just says that the sum of the voltages across a loop is equal to 0. We've seen that before. The junction rule just says that IN is equal to I out. So like for example on number 51, it's an application of the junction rule. I want to know the current coming here. I have my incoming currents, 8, 4, and 2. Since they're all incoming, I know that the current in this branch has to be outgoing because there are no other outgoing currents. So I have 8 plus 4 plus 2. That's equal to 14 amps. And so that's my outgoing current. That's the junction rule. And it's true for any circuit. So for example, here, I1 and I2 are coming in. And so I'd have I1 plus I2 equals to I3. That's the incoming equal to the outgoing current. Notice that in this circuit, I have 3 different currents. Let me show you. The currents go between junctions. I have a current that starts here and goes around to there. I have another current, I2, that's through that circuit, through that junction. And then I have another current that looks like that. I've given directions for the currents here, but let me tell you something about the directions of current in multi-loop circuits. You just make them up. Like in the beginning of the problem, and I'll show you this tomorrow, but in the beginning of the problem, you just decide what is the direction of the current that you want to choose. And then later, after you work through the problem, you'll figure out if you chose correctly or not. Because if the answer comes out negative, that means that you chose it incorrectly, and you just changed the direction of the current. Okay, so that's the junction rule, and that's how I apply the junction rule. The incoming current is equal to the outgoing current. The way that I apply the loop rule will look something like this. I'll pick a loop first of all. So like I'm going to pick this loop right here, the top loop. How many loops are in this multi-loop circuit? 1, 2, 3, 4. How many loops are there? Distinct loops in this multi-loop circuit. Let me give you, it's not 2. There are more than 2 loops. How many are there? There are 3 loops. There's the top loop, there's the bottom loop, and then there's the what? The outer loop, the big loop. So there are actually 3 distinct loops. And we can write the loop rule for each of those loops. Let's just write it for the top one. I'm going to just write it out, and then I'll explain to you the signs. I have 14 volts minus I1, 4I1, plus 10, plus 6I2. And that's all equal to 0. We have some rules when we're writing out the loop rule. And they're all, I think they're all, oh no, 3 of them, or 2 of them are here. If I'm going across a battery in this direction, so I'm traveling in this direction, that voltage is positive. That's sort of the normal way. And so when I went across the 14-volt battery in this direction, I wrote positive 14 volts. However, if I've been going across the battery in the opposite direction, that would be a negative voltage. And so if I had instead chose to go around the loop in this direction, this would have been negative 14. Because I always like to think of it as you're going the wrong way on this battery. You're going from the big side to the negative side, and that's sort of the wrong way. Electricity doesn't flow that way. Do you know what's the situation where you might have current flowing from the big side to the little side on a battery? When it flows from the little side to the big side, your electrons gain energy. But when it flows from the big side to the little side, from positive to negative, your electrons lose energy. Why would you want your electrons to lose energy going into a battery? No. When you're charging your battery, So when you charge your battery, that's what you do. You flip the leads. I mean, you have to have a special battery, right? But those electrons' energy in the current is actually deposited into the battery. Anyway, so it's not that important right now. Okay, so then when I'm going, I have two other rules. When I have a resistor and the current is going in that direction, and I'm traveling in this direction as I'm writing my loop rule. So we have two directions at play here, the direction of the current and the direction that I'm going around the loop, sort of the traveling direction. This is going to have a potential equal to negative I times R. And so that's where I saw this. I was going, when I came around this loop, I went across the 4 ohm resistor going in the direction of the current. Then my resistor saw a drop in potential. So I have a negative 4I right there. But notice here, am I going with or against the current with the 6 ohm resistor? With or against the current? Well, the current's flowing right to left, but I'm traveling left to right. So I'm going against the current. And so when I wrote it as a positive IR, a positive 6I2. And so that's the fourth rule, which we see there, which is if my current is flowing in that direction, but I'm traveling in that direction, then I have positive IR. And so that allows you to write equations for your multi-loop circuit. You can apply those loop rules across any loop within a circuit. Any loop. It doesn't even matter how complicated it is. You'll see some circuits that are really complicated. But the cool thing about the loop rule is that you can pull out any loop within that circuit, and this will always be true. It has to be true. The reason is because if I come back to any point in a circuit, the energy of the electron is going to be exactly the same. And so the sum of all the changes in energy for the electron will be equal to 0. Okay? I know that's sort of foreign to you, but we're going to see it tomorrow, so I think it's useful just to get a little preview of that. Let's do a problem. So let's try this number 50, and then maybe we'll do another combination circuit. What is the current through the 4 ohm resistor? I want to pick an equation, a loop, that will give me an equation that's easy to solve. Now, if you do the homework problem in your chapter, and we'll do one tomorrow in class, then you'll find that these can get really complicated. They involve solving a system of equations with two unknowns. I'm not going to make you do that on the test, though you need to know how to solve a system of equations. I think that you do, and you've had it, but it's a useful thing to know. But if you play your cards right, you'll be able to pick a loop. I want to know the current through the 4 ohm resistor. You'll be able to pick a loop that allows you to solve for this current, but without solving a system of equations. Now, I wrote this equation already. Notice it has that I1 in it right here, but it also has I2 in it. So I can't solve this. Now, I can solve a system of equations. I could write out say the bottom loop, and then I'd have a system of equations, and I could solve that. But a much easier way is to consider the big loop. So let's write the equation for the big loop. I will start here and go in this direction. I've already written the first part of that, 14 minus 4I1. What's my next portion of this equation? I'm coming down here. I'm doing the big loop. What do I write? Is it plus or minus 6? What do y'all think? Plus or minus 6? It's plus. Good. It's plus 6 because it goes by this rule right here. I'm going from little to big, so it's sort of how batteries are supposed to work. And this is all equal to 0. And so if I solve this for I1, I get negative 20 divided by 4. That's negative 5 amps. And so 5 amps is the right answer Oh, it's actually positive 5. Because that negative 4. If I chose, or if I calculated this and I find that it's negative 5, what that means is that I chose the direction for this current, no, not that current, the current up here, I1, that I chose it incorrectly. So where I have it counterclockwise, it would really be clockwise. Okie dokie. You want to do another combination circuit, or y'all brain fry? Brain fry? Brain fry? Okay, we'll stop there then. We'll be doing more of these though, and we'll have another help session on Tuesday, I'm pretty sure, before the test.